Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the completing the square practice questions. If you need any extra help on completing the square, if you go to corbettmaths.com/contents, you scroll down to videos number 10 and 267a. There's video tutorials there that may help you. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we've been asked to write x squared plus 8x plus 6 in the form of x plus a close bracket squared plus b, where a and b are constants. So in other words, we need to do completing the square to this quadratic. Okay, so in terms of doing completing the square for this quadratic, what I'm going to do is I'm going to open up my brackets and I'm going to write x, and then I'm going to look at the coefficient of x, and the coefficient of x is 8, so I'm going to half 8, which is 4, so it'll be plus 4, and then close bracket squared, so just half the number in front of the x term here, and half of 8 is 4, so it's plus 4, and then I've done close bracket squared. I'm now going to take away this squared. Well, 4 squared is 16, so I'm going to take away 16, and then I've still got the plus 6. So we've now got x plus 4, close bracket squared, minus 16 plus 6. Now let's simplify this. If you've got minus 16 plus 6, that's going to be minus 10. So that's going to be x plus 4, close bracket squared, minus 10. And that's it. And if you wanted to check your answer, you could write x plus 4 and then brackets x plus 4, expand those brackets and then take away 10 at the end, and you should get this. And that's it. So we've done that. We've written it in the form of x plus a, close bracket squared, plus b. And that's it. Okay, let's have a look at question number 2. So question number 2, we've been asked to write x squared plus 12x minus 1 in the form of x plus a, close bracket squared, plus b, where a and b are constants. So in other words, we need to complete the square to this quadratic. So we've got x squared plus 12x, so we're going to open up our bracket, we're going to write x, and then the coefficient, the number in front of the x is 12, so half of 12 is 6, so I'm going to then write plus 6, close bracket squared. I'm now going to take away whatever I get whenever I square this. 6 squared is 36, so take away 36, and then we've got our minus 1, so then our minus 1. Minus 36, take away 1 would be minus 37, so that'll be x plus 6, close bracket squared, minus 37. And that's it, we've done completing the square. We've written this quadratic in the form of x plus a, close bracket squared, plus b. And our answer is x plus 6, close bracket squared, minus 37. Okay, and that's it. Okay, let's have a look at our next question, question number 3. Okay, question number 3, we've been asked to express x squared minus 4x minus 9 in the form of x minus a, close bracket squared, minus b. So in other words, we need to do completing the square to this quadratic. So again, we're going to open up our brackets. It's x squared, so we're going to write x. Now the number in front of the x this time, the coefficient of x is minus 4, so half of minus 4 would be minus 2. So we're just halving this to get minus 2, and then close brackets, and then squared. Now we're going to square this. Minus 2 times minus 2 is 4, so we're going to take away 4. We always take away what we get when we square this. Minus 2 squared is 4, so we're then just taking away 4. And then we've got our minus 9 on the end, so minus 9. And minus 4 take away 9 would be minus 13, so the answer would be x minus 2, close bracket squared, minus 13. And that's it. We've written it in the form that we've been asked to, so we've done completing the square to that quadratic. Okay, and question number 4. Okay, question number 4, we've been asked to express x squared plus 6x plus 25 in the form of x plus a, close bracket squared, plus b. In other words, we've got to do completing the square to this quadratic. So let's open up our brackets. It's x squared, so we're going to write x. Now the coefficient of x is 6, so half of 6 would be 3, so plus 3, close bracket, squared. 3 squared is 9, so we're going to take away 9, and then we've got plus 25. Minus 9 plus 25 would be 16, so we're going to then have x plus 3, close bracket squared, plus 16. And that's it, we've done completing the square to our quadratic, and we've got our answer. Okay, next, question number 5. Okay, question number 5, it says Rosa has been asked to write x squared plus 10x plus 7 in the form of x plus a, close bracket squared, minus b. So in other words, we've got to do completing the square to this quadratic, or she's got to do completing the square to that quadratic. And here's her working out. Okay, so she's written down the quadratic. Okay, so that's right. She's then done, if we have a look inside the brackets, we've got x plus 10. Well, hold on a minute. The coefficient of x is 10. It's plus 10x. And half of 10 is 5. So this should be plus 5, not plus 10. So it should be x plus 5, close bracket squared. And then we would take away whatever we get when we square this. 5 squared is 25, so take away 25. And then we've got plus 7. So actually, she's then taken away 10 squared, which is minus 100, and then she's still got our plus 7. And that's our mistake. This shouldn't be plus 10. It should be plus 5. So let's explain that. And so the question says, is Rolls correct? And I've said no. Rolls should have halved the 10 to give x plus 5, close bracket squared. And then also, it shouldn't be minus 100 plus 7. It should be minus 25 plus 7. And that's it. And the actual answer would be x plus 5, close bracket squared, minus 18. So that's it. Rolls is incorrect. Okay, next, question number 6. Okay, let's have a look at our next question, question number 6. So question number 6, we've been asked to write x squared minus 3x plus 7 in the form of x plus a close bracket squared plus b. So this time, instead of having something even in front of the x, it's odd. So it'd be the same approach. So you'd open up your brackets, and we would then write x. Now, it was minus 3. We're going to half that, so it's going to be minus 3 over 2. In theory, you could write minus 1.5 and do it that way if you wanted to. I tend to like it as a fraction, like so. And then close bracket squared. I'm then going to take away whatever I get whenever I square this. Well, minus 3 over 2 multiplied by minus 3 over 2 would be 9 over 4. So I'm going to take away 9 over 4. And then we've still got our plus 7, so plus 7. So we've now got this. We just need to simplify this part here. So we've got minus 9 quarters plus 7. So I'm going to write it as 7 over 1. And then I want to get a common denominator. So I'm going to multiply both the numerator and denominator here by 4. So it'll be minus 9 quarters plus, and multiplying both the numerator and denominator by 4 will be 28 quarters. So we've got minus 9 quarters plus 28 quarters. And minus 9 quarters plus 28 quarters, well, that would be equal to, well, it's still going to be quarters, and minus 9 plus 28 is equal to 19. So that'll be equal to 19 quarters. So that means our answer will be x minus 3 over 2, close bracket squared, and then plus 19 quarters. And that's it. That's our answer. Okay, let's have a look at our next question, question number 7. So question number 7 says, Georgina rewrites the expression x squared plus px plus q by completing the square. And she correctly obtains x minus 5, close bracket squared, plus 31. And we've been asked to work out the values of p and q. So we want to work out the value that was in front of the x, so the coefficient of x, and the constant on the end. So in terms of this, well, we know what her answer is. We've got x minus 5, close bracket squared, plus 31. Well, if we expand this and see what we get, then we can find the values of p and q. So let's just expand this. So instead of it being x minus 5, close bracket squared, plus 31, I'm going to write the bracket beside itself, because when you're squaring a bracket, you're multiplying it by itself. So x minus 5, bracket x minus 5, close brackets, and then we've got our plus 31. Now let's expand our brackets. X times x will be equal to x squared. X times minus 5 would be minus 5x. Minus 5 times x would be minus 5x again. And minus 5 times minus 5, well, negative times a negative is a positive, so it's going to be plus 25. And we've still got our plus 31 on the end. Now we just need to simplify this, so that's going to be x squared. Minus 5x minus another 5x, that'll be minus 10x. And then we've got 25 plus 31, that's going to be 56, so plus 56. So we've expanded this and we've got x squared minus 10x plus 56. But now we wanted to find the values of p and q. Well, in terms of p is going to be minus 10. So p is equal to minus 10, because that's the coefficient of x, minus 10. And the q is going to be equal to 56. Q is equal to 56. And that's it. Okay, let's have a look at our next question, question number 8. So question number 8, we've got x squared minus 4x plus b is equivalent to x plus a, close bracket squared, plus 11. And we've been asked to work out the values of a and b. Okay, now if we have a look at this, if we were to start off with this left-hand side and we were to do completing the square, so the first thing we would do is we would half the coefficient of x, so the thing in front of the x here is minus 4, and if we half that, it'll be minus 2, and we put that in the bracket here. So that means that a is equal to minus 2, because if we had this, if we were to do completing the square, the first step would be to write x, and then we would half this, it'll be minus 2, close bracket squared. And then we would take away whatever that is squared. So minus 2 squared would be equal to 4, because minus 2 times minus 2 is 4. So we'd take away 4, and then we would put our plus b on the end. So that's what we'd get if we were to do completing the square on this. And we've been told that's equivalent to x plus a, close bracket squared, plus 11. So it means that a is equal to negative 2. So a is equal to minus 2, because it's just half the coefficient of x. Now in terms of our b, if we want to find out what b is, well, if we have a look at this, well, we've done completing the square on the left hand side and we've got this. Well, if we have a look at the right hand side, that's equivalent to, we've got x plus a, well, a is minus 2, so it's going to be x minus 2, close bracket squared, and then we've got plus 11. Now if we have a look here at the things outside of the brackets, because we've got x minus 2, close bracket squared on both sides, but in terms of the thing outside of the brackets, we've got minus 4 plus b is equal to 11. So let's write that down. Minus 4 plus b is equal to 11. So that means that if we add 4 to both sides, we're going to get that b is equal to 15. So b is equal to 15. So we've got a is equal to minus 2 and b is equal to 15. And that's it. Okay, so let's have a look at question number 9. So question number 9, we've got x squared plus 5ax plus b is equivalent to x plus 20, close bracket squared, minus 3a. And we've been asked to work out the values of a and b. So in terms of this question, well, if I was to do completing the square on this left-hand side, I would open up my brackets, I would write x, and then I would half the coefficient of x, and that's given me 20. So if I take this 20 and I multiply that by 2, that'll give me the coefficient of x here. So 20 multiplied by 2 is equal to 40. So that means that this 5a is equal to 40. So 5a is equal to 40. And if we divide both sides by 5, we get that a is equal to 8. So that means that a is equal to 8 here. So a is equal to 8. Now we then want to work out the value for b. Well, if we have a look at this, well, we would have, let's just substitute 8 into this to find out what we would have then. So we'd have x squared. We've then got plus, and 5 times 8 would be equal to 40x. And then we've got plus b is equivalent to, and then on the left hand side we've got x plus 20 close bracket squared, and then we've got minus 3a. Well, a is equal to 8, 3 times 8 is 24, so minus 24. Okay, that's fantastic, because now if we expand these brackets and simplify, let's see what we get. So let's focus on this right hand side. We'd have x plus 20 squared, so it's going to be x plus 20, and then in brackets x plus 20, and then close brackets, and we've got minus 24. So if we expand this, so x times x is x squared, x times 20 and 20 times x, that'll be plus 20x plus another 20x, and then 20 times 20 would be plus 400, and then we've got our minus 24. And then if we simplify this, we'd have x squared, 20x plus 20x is 40x, so plus 40x, and then we've got 400, take away 24, that's equal to plus 376. So we've now got that this right hand side is x squared plus 40x plus 376. On the left hand side we've got x squared plus 40x plus b, so that means that b is 376. And that's it. Okay, let's have a look at our next question, question number 10. So question number 10 says that x squared minus 6x minus 3 is equivalent to x minus a close bracket squared minus b, where a and b are constants. And we've been asked to find the values of a and b. In other words, we need to do completing the square to this quadratic on the left hand side. So in terms of doing completing the square to this quadratic, so let's open up our brackets and write x. The coefficient of x is minus 6, so let's half that. That's going to be minus 3 close bracket squared. Minus 3 squared is 9, so we're going to take away 9, and then we've got our minus 3. And now we just need to simplify this, so we're going to have x minus 3 close bracket squared, and minus 9 minus 3 would be minus 12. And we've been asked to write down the values of a and b, and because it's x minus a close bracket squared minus b, that means that a is equal to 3 and b is equal to 12, because we're taking away 3 and we're taking away 12. Okay, next, part b. Part b says hence solve x squared minus 6x minus 3 is equal to 0. So we want to solve this quadratic using completing the square. Now we've already done completing the square to this left hand side here. That's equal to x minus 3 close bracket squared minus 12. So if we were to do completing the square on this left hand side, you would get this. So that's equal to 0. Now we just need to solve this. So let's add 12 to both sides. So that'll give us on the left hand side x minus 3 close bracket squared. And on the left hand side, we're adding 12 to both sides. So that'll become 0. And on the right hand side, you get that's equal to 12. Okay, now we want to get rid of the squared here, so that would leave us on the left hand side x minus 3, and the right hand side, well, that would be the square root of 12, but be careful, it would be root 12, but it would also be negative root 12, because root 12 squared would be 12, and negative root 12 squared, well, negative root 12 times negative root 12 would also be equal to 12, so we're going to get plus or minus the square root of 12. And now we also want to get rid of this minus 3, so let's add 3 to both sides. Now if we add 3 to both sides, on the left hand side we'll just be left with x. On the right hand side, whenever I add 3 to both sides here, I'm going to have 3. Well, I'm going to put that in front of the plus or minus, so I'm going to have 3 plus or minus the square root of 12. So if we go up here, we've got x is equal to 3 plus or minus the square root of 12. Now in terms of finding our two solutions, that means that x would be equal to 3 plus the square root of 12, or x equals 3 minus the square root of 12. Okay, so we've now got our two solutions, the x equals 3 plus the square root of 12, and the x equals 3 minus the square root of 12. But actually, root 12 can be simplified. So root 12, to simplify a third, you think, what's the biggest square number that's a factor of 12? That'll be 4. So that'll be, if you split this up, it'd be root 4 multiplied by root 3, because root 4 times root 3 is root 12. And 4 is a square number, and the square root of 4 is equal to 2, so that'll be 2 root 3. So that means our solutions would be x equals 3 plus 2 root 3, or x equals 3 minus, and instead of writing root 12, we're going to write 2 root 3, 2 root 3. And there are solutions, 3 plus 2 root 3 and 3 minus 2 root 3. And that's it. Okay, let's have a look at our next question, question number 11. So question number 11, we've been asked to solve this quadratic using completing the square. So let's do completing the square on this left-hand side. So that'll be open brackets and then x. And then the coefficient of x is minus 6. So if we half that, it'll be minus 3, close bracket squared. Minus 3 squared is 9, so then be minus 9. And then we've got our plus 2, and that equals 0. Minus 9 plus 2 is equal to minus 7, so we're going to have x minus 3, close bracket, squared, and then minus 9 plus 2 is minus 7, equals 0. Now we want to solve this, so let's add 7 to both sides. That'll give us x minus 3, close bracket, squared. Adding 7 to the left hand side gives rid of this minus 7, and the right hand side you would have then that's equal to 7. Now we want to get rid of the squared, so if we get rid of the squared we would have x minus 3, and that's equal to plus or minus the square root of 7. And now we just want to add 3 to both sides. We get x, and I tend to put this 3 in front of the plus or minus, so you'd have 3 plus or minus the square root of 7. So there's our two solutions. The x equals 3 plus the square root of 7, or x equals 3 minus the square root of 7. And that's it, there are two solutions. Okay, let's have a look at our next question, question number 12. Okay, question number 12, we've been asked to solve another quadratic using completing the square, and we've been asked to give our answers in third form. Obviously, this is a non-calculator question. So, because we've been asked to use completing the square, let's do completing the square on the left-hand side. Because it equals 0, we're going to do completing the square on this left-hand side here. So, open up brackets, x. We're going to half the coefficient of x, so half of 4 is 2, so plus 2, close bracket, squared. 2 squared is 4, so we're going to take away 4, and we've still got our plus 1, so plus 1. And that's equal to 0. Now, minus 4 plus 1 is equal to minus 3, so that's x plus 2, close bracket, squared. Minus 3 is equal to 0. And then, because obviously minus 4 plus 1 is minus 3, and then I add 3 to both sides, gives us on the left hand side x plus 2, close bracket, squared. On the right hand side, that's equal to 3. Okay, now we want to get rid of the squared, so we're going to have x plus 2, and that's equal to plus or minus the square root of 3. And then finally, we want to get rid of this 2 here, so we're going to take away 2 from both sides. So on the left hand side, we'll be left with x. And on the right hand side, we're taking away 2. I like to put it in front of the plus or minus, so I'm going to write minus 2 plus or minus the square root of 3. Now, we've been asked to write our answers in third form, so that means that one answer would be x equals minus 2 plus the square root of 3, or x equals minus 2 minus the square root of 3. So there are two solutions, and that's it. Let's write those down. And there are two solutions, and that's it. Okay, let's have a look at our next question, question number 13. So question number 13, we've been asked to use completing the square to solve this quadratic. Now equals 0, that's fantastic. So on the left hand side, we just need to do completing the square. So open up our brackets, x, and then our coefficient of x is minus 14, so let's half that, that's minus 7, close bracket, squared. Minus 7 squared is equal to 49, so we're going to take away 49, and then we've still got to put our minus 2 after that, and that's equal to 0. Now minus 49, take away 2 is minus 51, so we're going to have on the left hand side x minus 7, close bracket, squared. Minus 49, take away 2 would be minus 51, and that's equal to 0. Now we want to solve this, so let's add 51 to both sides. So on the left hand side we'd have x minus 7, close bracket, squared. And on the right hand side we'd have that's equal to 51. Now we want to get rid of the squared, so that's going to be x minus 7, and then we're going to have that's equal to plus or minus the square root of 51. And then we just need to add 7 to both sides, so it's going to be x equals 7 plus or minus the square root of 51. And that means our two solutions are x equals 7 plus the square root of 51, or x equals 7 minus the square root of 51. And there are solutions, and that's it. Okay, let's have a look at our next question, question number 14. And question number 14, we've been asked to do completing the square to this quadratic. Now this one's a bit different because all the quadratics we've been doing completing the square to so far have just been x squared or 1x squared. This time we've got 3x squared. So in terms of this question, if you've looked at the answers already, you'll see I've used two different approaches. So I'm actually going to do two different approaches in this video. Okay, so in terms of the first approach, because it's 3x squared plus 18x minus 1, I'm actually going to start off by taking out 3 as a factor of all of this. So if I take 3 out, I'd have 3, and then in brackets, I'm actually going to use square brackets here, and then I'm going to take 3 out, so I'm going to divide all of these by 3, so that'll give me x squared plus 6x, and then here if we divide this by 3, it'll be minus a third. So we've just divided everything in the bracket by 3, and if we were to expand our brackets, 3 times x squared is 3x squared, 3 times 6x is 18x, and 3 times minus a third would be minus 1. So we've just taken out the 3 out of all of that. Now we're going to do completing the square on what's inside the square bracket. So I've got our 3 and then our square bracket, and now we're going to do completing the square on this. So we're going to open up our brackets, our curvy brackets this time, and we've got x. Now we've got plus 6x, so the coefficient of x is 6, half of that would be 3, so plus 3, close bracket squared. We're now going to take away this number squared, so take away 3 squared is 9, so take away 9, and we've still got our minus a third, so here minus a third, and then we've got our square brackets. Okay, so we've done our first bit of completing the square here. Now let's simplify this. So 3 square brackets. Now let's simplify what's inside the square brackets. So we've got x plus 3 close brackets squared, and then we've got minus 9 minus a third. Now in terms of minus 9 minus a third, that's minus 9 minus a third. Well, I'm going to call this minus 9 over 1, so it's minus 9 over 1 minus a third. We want the same denominator, so let's multiply both the numerator and denominator of this fraction by 3, so it'll be minus 27 over 3 minus a third. And minus 27 thirds minus another third would be minus 28 thirds, so minus 28 thirds. So this is a top-heavy fraction, would be minus 28 thirds. You could have written down minus 9 and a third that way, and then whenever you multiply later you could work that out, but I've just written as a top heavy fraction by just doing minus 9 take away a third. Okay, and then close our square brackets. Okay, we're almost done. If we have a look at what we're trying to get to, we've got something multiplied by our bracket squared and then plus a constant. Well, if we expand our brackets here, 3 multiplied by the bracket would be 3 bracket x plus 3 close bracket squared. And then we've got our minus 28 thirds, and we're going to multiply that by 3, so obviously that's just going to be equal to minus 28. And that's it. We've expressed this quadratic in the form that we've been asked to. And the answer would be 3 brackets x plus 3 close bracket squared minus 28. So that was one approach. Let's have a look at the other approach. Okay, and in terms of our second approach, rather than factorising the whole thing and taking 3 out of the whole thing here, what we could have done was just focus on the first two terms. So we would have our 3, open up our square brackets, and then that would leave us with x squared plus 6x, and then close our brackets, and then we'd have our minus 1. So just factorising the first two terms, taking out the 3 and leaving the minus 1 outside. Okay, now we're going to do completing the square and what's inside the square bracket. So it's going to be 3 and then our square brackets, and then open up our brackets, x, and then half the number in front of the x. So half of 6 is 3, so plus 3, and then close bracket squared. And then take away whatever this is squared. 3 squared is 9, so take away 9. Then there's nothing else inside the brackets here, so we're just going to close our brackets, and then we've still got our minus 1 outside. And now we're almost done. We just need to expand our brackets. 3 times this bracket would be 3 brackets x plus 3 close bracket squared. We've got minus 9. We're timesing that by 3, so it's going to be minus 27. And then we've still got our minus 1. And minus 27 minus 1 will be minus 28. So it'll be 3 bracket x plus 3 close bracket squared minus 28. And that's it. So there are two different approaches we could use. We could take 3 out of everything, or just take the 3 out of the first two terms. And that's it. Okay, let's have a look at our next question, question number 15. Okay, let's have a look at question number 15. So question number 15 is very similar to question number 14. So I'm going to do this question again in two different approaches. So in terms of our first approach, let's take 3 out as a factor. So we'd have 3 and then in brackets, our square brackets. And then if we divide everything by 3, we would get x squared minus 4x plus, and then we're dividing 4 by 3, so it's going to be 4 thirds, just put it over 3, and then close brackets, our square brackets. And if we check this, if we multiply x squared by 3, we'd get 3x squared. If we multiplied minus 4x by 3, we'd get minus 12x, and if we multiplied 4 over 3 by 3, we'd get 4. Okay, so we've taken the 3 out as a factor. Now what we're going to do is we're going to do completing the square on what's inside the brackets. So let's do our 3 and then our square bracket. And now we're going to do completing the square. So let's open up our curvy brackets and then do x. And then we're going to half the number in front of the x. So that's minus 4, so half of that's minus 2, close bracket squared. Now we're going to square this. Minus 2 squared is 4, so it's going to be minus 4. And then we've still got our plus 4 thirds, so plus 4 thirds, and then close our square brackets. So we've done completing the square and what's inside the brackets. Now we just need to simplify this. We've got minus 4 plus 4 over 3, so let's work out what that would be. So minus 4 plus 4 over 3. Well, let's call our minus 4 over 1, just call it 4 wholes. So now let's get a common denominator. Well, we've got 1 and 3, so let's make that 3, so that's going to be 4 thirds there. And if we multiply both the numerator and denominator here by 3, we'd get minus 12 thirds. And then minus 12 thirds plus 4 thirds will be minus 8 thirds, so minus 8 thirds. And that's it. So this part will be minus 8 thirds. So that'll be 3 square brackets, curly brackets, x minus 2, close brackets squared, and then it's going to be minus 8 thirds, and then close our square brackets. And now we just need to multiply everything by 3, so that'll be 3 bracket x minus 2, close bracket squared, and then we've got minus 8 thirds times 3. Well, we're dividing by 3, we're timesing by 3, so that'll just be minus 8. And that's it. So we've written this quadratic in the form of a bracket x plus b, close bracket squared, plus c, where a, b, and c are constants. So a would be 3, b would be minus 2, and c would be minus 8. And that's it. Okay, so in terms of the other approach, rather than taking 3 out of everything, I'm going to just focus on the first two terms. So I'd have 3 and then our square brackets. And if we divide both of these by 3, we would have x squared minus 4x, close our square brackets, and then we've still got our plus 4, just taking the 3 out of the first two terms. Now we're going to do completing the square on what's inside the bracket. So we'd have 3 and then our square brackets, and then we'd have our little curvy brackets, x minus 2, close bracket squared, just halving the minus 4 to get minus 2. And then we're going to take away that squared. Well, minus 2 squared is 4, that's going to be minus 4. And then close our square brackets, and then we've still got our plus 4. And then if we just multiply here by 3, we would get 3 bracket x minus 2, close bracket squared. We'd minus 4, we're times it by 3, that's going to be minus 12, but we've still got then our plus 4. Minus 12 plus 4 would be minus 8. So then that would give us 3 brackets x minus 2, close bracket squared. And then we'd have minus 8. And that's what we got in the other approach as well. And that's our answer. Okay, let's look at question number 16. Okay, let's have a look at our next question, question number 16. Now, completing the square can be used to find the minimum point or the maximum point of quadratic graphs. So here we've got a quadratic, y equals x squared minus 6x plus 1. And to find the minimum point, what we're going to do is we're going to do completing the square on the quadratic. So let's do that. So we'd have y equals, and then open up our curved brackets. We'd have x. We've got the coefficient of x is minus 6, so we're going to half that. That's going to be minus 3, close bracket squared. Minus 3 squared is 9, so we're then going to take away 9, and then we've still got our plus 1. Now if we simplify this, we'd have y equals x minus 3, close bracket squared, minus 9 plus 1 would be minus 8. So that's what we get when we do completing the square. Okay, so we've now done completing the square. Now this is really, really useful. So what I'm going to do is I'm going to do a little sketch. Okay, so this is the graph of y equals x squared. So that's the graph of y equals x squared. Obviously, it passes through the origin. We'd have the points 1, 1, 2, 4, 3, 9, and so on. Minus 1, 1, minus 2, 4, and so on. So that's the graph of y equals x squared. Now, by using our knowledge of transformations of graphs, we can figure out where this graph would move to if we consider these transformations. Y equals f of x minus 3, close brackets, minus 8. Because if we let y equals x squared be the function of x, then the function we're looking at has a minus 3 in the bracket, and then it's got the minus 8 outside. Now, if we consider our transformations of graphs, what's inside the bracket would move the graph horizontally, either left or right. Minus 3 inside the bracket would move the graph 3 squares to the right. It's counterintuitive. You would think with minus 3 being in the bracket, it would move 3 squares to the left. It actually translates the graph 3 squares to the right. Then we've got minus 8 outside of the brackets. That would translate the graph 8 squares downwards. So by considering transformations of graphs, this would translate the graph 3 squares to the right, so it would move it 3 squares to the right, and then 8 squares down, so 8 squares down. So that means this quadratic graph would have a minimum point here of 3 minus 8. So the coordinates of the minimum point of this quadratic curve would be 3, negative 8. And to do that, we just done completing the square to get y equals x minus 3, close bracket squared, minus 8. Then we considered our transformations of graphs, and that would be, we've got our minus 3 inside the bracket. That would translate the graph, the x squared graph, 3 squares to the right. And then we had minus 8. That would translate it 8 squares down. So that would be the graph of y equals x squared minus 6x plus 1. And the coordinates of the minimum point would be 3 minus 8. And that's it. Okay, let's have a look at our next question, question number 17. It's very similar to question number 16, so we're going to use completing the square to find the minimum point of this quadratic graph. So in terms of this graph, I've actually just sketched y equals x squared to begin with, and what we're going to do is we're going to do our completing the square on this quadratic and see what we get. So we're going to have y equals, and then open up our brackets, x. We're going to half the number in front of the x, so the coefficient of x, which is 4, so this would be plus 2, close bracket squared. We then square this, so 2 squared is 4, so we're going to take away 4, and then we've got plus 7. So we've got y equals x plus 2, close bracket squared, minus 4 plus 7. Minus 4 plus 7 is 3, so that'd be y equals x plus 2, close bracket squared, and then minus 4 plus 7 would be 3, so plus 3. So we've done completing the square on the quadratic, so we've got y equals x plus 2, close bracket squared, plus 3. Now we're going to consider our transformations of graphs, because if we let this y equals x squared graph be the function of x, then this would be y equals f of x plus 2, because we've got the plus 2 inside the brackets, and then we've got plus 3 outside. So in terms of these transformations, we've got a plus 2 inside the bracket. That would translate the graph 2 squares to the left, because remember it's counterintuitive. If it's plus, you move the graph to the left. If it's subtract, you translate the graph to the right. And then outside the brackets, we have plus 3, so that would translate the graph 3 squares upwards. So that's what the graph of y equals x squared plus 4x plus 7 would look like. It would look something like that. And the coordinates of the minimum point, where we translated the graph 2 squares to the left, so that would be minus 2. And then we translated it 3 squares upwards, so that would be 3. And that's it. So the coordinates of the minimum point of that quadratic curve would be negative 2, 3. And that's it. Okay, let's have a look at our next question, question number 18. So question number 18, we've got y equals x squared minus 10x plus 20. And part A says we've been asked to write this quadratic in the form of x minus a, close bracket, squared minus b. So we need to do completing the square to this. So that's going to be open brackets, x, and then we've got the coefficient of x is minus 10, so half of that would be minus 5, close bracket, squared. Minus 5 squared is 25, so we're then going to take away 25, and then we've got our plus 20. Now, if we then simplify this, we would have x minus 5, close bracket, squared. We've then got minus 25 plus 20, so if we go back up 20, that would be minus 5. So that means it would be x minus 5, close bracket, squared, minus 5. And that's it, we've done completing the square, and we've got it in the form that we've been asked to. Okay, next, part B says write down the equation of the line of symmetry of y equals x squared minus 10x plus 20. So actually the graph kind of covers, this is the y equals x squared graph. I've just put that there to help us, but actually it covers the writing, so I'll just read that again. Write down the equation of the line of symmetry of y equals x squared minus 10x plus 20. So we've actually done the completing the square in this, and we've got this y equals x minus 5, close bracket, squared, minus 5 if we do completing the square. Now, in terms of what that graph would look like, well, if we consider that y equals x squared graph, we've got minus 5 inside the brackets, so that would translate the graph 5 squares to the right. And that's actually enough for this question for us to be able to work out the answer. And then we're going to translate the graph 5 squares down. So we're going to translate it 5 squares down. So that would be the graph there. Actually, I'm just going to write down the coordinates of the minimum point here, which would be 5, because we translated it 5 squares to the right and then 5 down. So it'd be 5 minus 5. So that's that point there. Now we've been asked to write down the line of symmetry. Well, the line of symmetry would be a vertical line of symmetry, like so. And it would pass through 5 in the x-axis. So the equation of that line would be x equals 5. The mirror line is x equals 5. And that's it. That's the equation of the line of symmetry. Okay, let's have a look at our next question. Okay, question number 19. So question number 19a says write x squared plus 8x minus 7 in the form of x plus a, close bracket, squared minus b. So we need to do completing the square on this. So let's do completing the square. So we're going to open up our brackets, x. We're going to half the coefficient of x. So the coefficient of x is 8, and we half that, that'll be 4. So plus 4, close bracket, squared. Now 4 squared is 16, so we're going to take away 16, and then we've got minus 7, so minus 7. And then if we simplify this, that'll be x plus 4, close bracket, squared. And minus 16 take away 7, well, if we go down another 7 from minus 16, that'll be minus 23. So that would be x plus 4, close bracket, squared, minus 23. Okay, now if we have a look at our next part, part B. Part B says we want to solve the equation x squared plus 8x minus 7 equals 0. So we've got this quadratic equation, and actually the quadratic on the left-hand side we've done completing the square on. So let's actually just write this out. I'm just going to change colour of ink so we know we're doing this part B here. X squared plus 8x minus 7 equals 0. But we've done completing the square on this, so that'll be x plus 4, close bracket, squared, minus 23 equals 0. Just replacing what we had with what we got whenever we done completing the square. Now, if we want to solve this equation, the first thing you would do is we would add 23 to both sides. So that would give us x plus 4, close bracket, squared, equals 23, just adding 23 to both sides. Now we want to get rid of this square root, so we're going to get rid of that. So that would give us x plus 4 equals, and then we're going to have plus or minus the square root of 23. And then we want to get rid of this 4, so we're going to take 4 away from both sides. Now, instead of writing minus 4 at the end, I tend to put it in front of the plus or minus, so I'd have the x equals minus 4 plus or minus the square root of 23. And I'm just going to write this out twice. So I'm going to write x equals minus 4 plus the square root of 23, or x equals minus 4 minus the square root of 23. And that's it. There are two solutions. So let's say we've been asked to write it in third form. The root 23 can't be simplified. So we've got minus 4 plus the square root of 23 and minus 4 minus the square root of 23. And that's it. Okay, let's have a look at part C. So part C, we've been asked to sketch the graph of y equals x squared plus 8x minus 7. And we've been asked to show the coordinates of the turning point and the coordinates of any intercepts with the coordinate axes. So in other words, if it crosses the x-axis, we need to write down where it crosses the x-axis and also where it crosses the y-axis. So in terms of this graph, so first of all, let's find out where it crosses the y-axis. To find where a graph crosses the y-axis, you let x equal 0, because obviously you're going 0 along. So whenever x equals 0, we would have y equals 0 squared plus 8 times 0 minus 7. That would be equal to y equals 0 squared is 0, 8 times 0 is 0, add them together is 0, take away 7 would be minus 7. So it means this graph crosses the x-axis at minus 7. So it crosses the x-axis at minus 7, so down here somewhere, minus 7. Okay, now let's find where it crosses the x-axis. Well, whenever it crosses the x-axis, we know that y is equal to 0. And actually, if we go back up to part B, here we had that y was equal to 0. We solved the quadratic equation. So we now know that it crosses the x-axis at minus 4 plus the square root of 23 and minus 4 minus the square root of 23. So let's write that down. Okay, so start off with minus 4 minus the square root of 23. Well, that's going to be over here somewhere because minus 4 minus the square root of 23 will be over there somewhere. So that'll be minus 4 minus the square root of 23. 0. That's the coordinates to that point. And in terms of this point here, well, actually, just want to find out if it's to the left or to the right of the y-axis. So it's minus 4, so that's minus 4. And then the square root of 23, well, the square root of 16 is 4, and the square root of 25 is 5. So that's going to be 4.7, 4.8, 4.9, something like that. It's going to be close to being 5. So minus 4 plus something like 4.7 or 4.8 will be positive. So it's going to be over here somewhere. So that'll be minus 4 plus the square root of 23. 0. So they're the coordinates where it crosses the x-axis, and actually we need to write this as a coordinate, so let's just change our y-intercept to a coordinate. Okay, so we've now found the coordinates of where the graph crosses the x-axis and where it crosses the y-axis. Now we also have been asked to find the coordinates of the turning point. Actually, so let's just sketch our quadratic. Okay, so that's a little sketch of the quadratic, and I've tried to get it to go through those points. Now we want to find the coordinates of the turning point as well. Okay, so now let's consider the coordinates of the turning point. Now if we go back up to point A, we had done completing the square, and we had got it in the form of x plus a close bracket squared minus b, like so. So that we've got this. So remember our transformations of graphs. So if we had the x squared graph, this would translate it 4 squares to the left, so it'd be 4 squares to the left, and this would translate it 23 down. So that would be the point here. That would be minus 4 minus 23. Make sure you close your brackets there. So that would be minus 4 minus 23, because remember, if we've got our x squared graph, the plus 4 inside the brackets is counterintuitive. It translates it 4 squares to the left, then the minus 23 translates it 23 squares down. And that's it. So we've now sketched our quadratic graph, and we've got the coordinates of where it crosses the x-axis, the y-axis, and the coordinates of the turning point. Okay, let's have a look at our last question, question number 20. So we've got the nth term of a sequence, n squared minus 6n plus 13. So it's a quadratic sequence, which is in the form of an squared plus bn plus c. And we've been asked to use completing the square to show that every term is positive. So let's do completing the square to begin with. So if we do completing the square on this, what would we get? So we would open up our brackets, we would have n. The coefficient of this n term is minus 6, so if we half that out, it'll be minus 3, close bracket squared. Minus 3 squared is 9, so we're going to then do take away 9, and then we've got our plus 13. Now minus 9 plus 13 is 4, so that'll be n minus 3, close bracket squared, plus 4. So we've done the completing the square, and we've got n minus 3, close bracket squared, plus 4, so that we've written this in this form. Now we've been asked to show that every term is positive. So let's start off with this bracket squared. Well, if we consider our n minus 3, close bracket squared, well, that would have to be bigger than or equal to 0, because if it was positive and you square it, you get a positive. If it's a negative and you square it, you get a positive. And if n was equal to 3, then you're going to get 3 minus 3 is 0, squared is 0. So this bracket squared will always be bigger than or equal to 0. It can't actually be negative. Then if we add 4, well, if you add 4 to it, well, the lowest it can be 0. If you add 4, that'll be 4. So that means that n minus 3, close bracket squared, plus 4 would always be bigger than 0. So we've got n minus 3, close bracket squared, plus 4 is always bigger than 0. And that's fantastic, because that means that every term in the sequence must be positive. So let's write that. And that's it. So just to recap, we took the nth term, we did completing the square, so we got n minus 3, close bracket squared, plus 4. The n minus 3 squared part, well, that would always have to be bigger than or equal to 0. So therefore, n minus 3, close bracket squared, plus 4 would always have to be bigger than 0. So that means that every term in the sequence must be positive. And that's it. And that's it. So these have been the video solutions to the completing the square practice questions on Corbettmaths. I really hope you found this video useful. If you need any extra help on completing the square and these types of questions, if you go to videos 10 and 267a, there's video tutorials there on different parts of completing the square. So I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. Thank you. Cheers. Bye.